Okay, welcome to the first video from Chapter 15, Time Series. So as the book correctly points out, the first thing you want to do whenever you're looking at time series data is you want to graph it. So the easiest way to do this, and this is the gasoline. I've got all the files that the book used so you can see how to graph everything. The first thing you want to do is highlight your variable, your time series variable. So in this case, it's the sales of gasoline. So this is thousands of gallons of gasoline. Highlight this. And the reason for this, as the book points out, is you always want your time series variable on the vertical axis and then your time periods on the horizontal axis. So the easiest way to do this in Excel is to highlight your time series variable and then go to Insert and then pick the line chart, Insert Line Chart, and just pick the first one. Voila, there you go. Now, I always recommend to my students that you move the chart out of your data file. See, right now my chart is covering up my sales data. So I like to move the chart, just put it into a new sheet and hit OK, and voila. So now, here's my pretty little chart, and here's my data. Okay, so what's the purpose of graphing this? Well, as your book points out, the type of time series that we're dealing with is going to help determine what forecast method we should use. And this first one, like with this gasoline chart, this is what we call a stationary time series. And so what that means is that the average gasoline sales is constant for each of these time periods, right? But there's this random fluctuation around the average, okay? That's what we call a stationary time series. And the idea here is that the average for each time period is constant, and then so is the standard deviation or the variance, right? So all you have are these random fluctuations around an average. Well, the idea is if you have a stationary time period, or I'm sorry, a stationary time series, that informs us of the method that we should use to forecast, say in this case, week 13's anticipated sales. Now, with that said, what the book didn't mention, which was somewhat unfortunate, is, just looking at this data, it's hard to see if this is stationary or not. It turns out that in Excel, there's a very easy way to see if your data is stationary. And so to do that, go into, under your chart tools, you see design, go into add chart element, and go down here and pick a trend line. And the trend line that we want is the linear trend line. So now here's hopefully you can see this in your video. This little dotted line now is my linear trend line. Well, what I'm trying to get at is, and this is the easiest way to see this, if that trend line is flat, then your data is stationary, right? This indicates, so this trend line would actually be the average gasoline sales, right? And so notice how the average is just flat. It's the same for each time period. And then all we're seeing here is these random fluctuations above and beyond the average. So this would indicate to us that we have a stationary time series. Okay, now that we know that we have a stationary time series, we're going to use things like exponential smoothing, moving averages, to forecast future gasoline sales. All right? So knowing that this is stationary informs us of the forecast method that we're going to use. And again, the easiest way to see this is just to add that linear trend line. Okay, well, as you can imagine, there are other time series. And the next one that your book talks about is they have this revised gasoline. And so I'm going to do the same thing. Now, this is still stationary, but it's got a twist in it. So let me graph this for you. Okay, move the chart. Okay. So what's happening here, and these are the things that you have to be careful of when you're when you're looking at your data. It turns out, so if you read the book, that in week 12 they sign this new contract, right? And so, boom, they start selling more gasoline. Well, the idea here is that actually now you have two separate stationary time periods, right? Here, this was the original data that I just showed you, right? So we would have had a stationary time series, a flat trend line here. Well, then we have this unique event where we sign a brand new contract, and now what's happening is the data is still stationary, but now the average has moved up, right? And so this complicates things because in this case, you don't, for example, when you're trying to forecast next period's, period 23's forecast of gasoline sales, you want to ignore this, right? Because something fundamental has happened in the sale of gasoline. So the purpose of this is to say, look, you have to graph your data and take a look at it. So here, if you see a big break like this, then that needs to be an indication to you that something fundamental has changed. And the idea is that this old data here is probably not reflective of your new sales, and so you'd want to get rid of it. Literally, you don't want to use it. So then the question becomes, all right, well, if that's true, how do I handle this? Well, it's actually quite simple. Take a look here. So this contract took place in period 13, right? So now what you want to do is go back and just graph period 13 to period 22. So I'll go back to my data, and you can clearly see the break in my actual data, right? So now what I'm going to do, just highlight the second half of that data set, insert, voila. Okay, I'll move it again just so you can see it a little bit better. Okay, now look, this is that gasoline sales after my new contract. And again, I'll insert my trend line. Where are you? Trend line. And there, again, I have a horizontal trend line indicating that I have a stationary time series in the sense that my time series has, for each period, I have this average. That's what's shown by the trend line. And I just have these random fluctuations above and below that average. All right? And then as your book points out, the standard deviation is also constant for each time period. Okay. And then lastly, I want to show you, I graphed this second half of that gasoline sales, but notice that the horizontal axis is 1 to 10. Well, you really want this to be time period 13 to 22. So the way to correct for that is to put your cursor in your graph where it says plot area, right click, and select or hit select data, and then right here where it says horizontal category axis label, hit edit, and then just highlight the time periods that we graphed. So that would have been time periods 13 to 22. Hit OK. Hit OK. And look, now I've got time period 13 to 22. And now I would just use this subset of my data to forecast period 23. All right. So, just to reiterate, the point here is, be on the lookout for breaks like this in your data. If you do see them, then graph your data post the break and see what it looks like. All right? Okay, so that is your gasoline sales. So, moving on. We got that. I did this. Okay, seasonality. So I got to get, let's see, my umbrella sales. Umbrella. I feel like I'm forgetting something. I am a trend. I forgot one. bicycle sales. Okay. So in the gasoline data, we had what we call the stationary time series, right? So our data just randomly fluctuated around a constant average. Well, here we're going to look at some data that has a definite trend in it. So in other words, as our time increases, sales are going to increase on average. So how do we look at this? Well, same thing. First, always graph your time series. So I'm going to hit my time series variable, highlight my time series variable, and then I'm going to go to insert a line. Okay, I'll move the chart so you can see it better, and so that it doesn't cover up my data. All right, voila. So here, the same thing. Do the exact same thing. Go back to add chart element, trend line, hit linear. Now look at the difference. Here, that trend line is upward sloping. It is no longer constant, right? So this upward sloping trend line indicates to us that we actually have a trend in our data. In other words, there is no constant average, right? So the average per period is not the same. In fact, the average per period appears to be increasing. Hence the reason the trend line is an upward sloping line. If you could have a negative trend, right, where the sales would be decreasing. This is sales at Kmart, right? Per quarter, sales keep falling and falling. Well, that would indicate a negative trend in your data. Well, what's the point of all this? Well, if our data has a trend, right, then using things like moving averages and exponential smoothing may not be the best way to forecast this time series. Because now what we would want to do is to incorporate that trend into our forecast. All right? And so to do that, we're going to use some regression techniques. It's actually called a trend regression. Very easy, very basic. That's in a later section of this chapter. We'll get to that next week. The idea here is for you to see these different types of data. All right? So whenever you see an upward sloping trend line, you know that your data is not stationary. And now when we forecast, we want to include this increasing trend into our forecast. Okay, so there we have a trend. Oh, and then the next one, cholesterol. So here we have a nice linear trend, all right? You can also have nonlinear trends, and that is shown in my cholesterol data. So again, here's this cholesterol drug, and here are the sales. So, as always, let's graph this. Okay, let me move the chart. Okay. Well, the idea here is if you look at this, and it's going to be hard to see, but just bear with me. If I go in here and hit a trend line, and hit linear, this isn't going to be such a good fit, right? Because see here, I've got some discrepancies on the bottom half. I'm looking good here, but then here, my trend line is not as steep as my actual increases in my revenues, right? The idea here is this looks more non-linear. And so what you can do to see this is to go and say get the exponential trend line. And so let me delete. So this one that I've got highlighted here, I wonder if I can do this. Let me see here. There you go. That's not really helping. Yeah, it is. So the purple, but let me just see if I can format the trend line. All right. Well, this is pretty. Oh, here we go. Color width. Oh, there you go. So now you can see That would be my linear trend line, and then check this out. Here would be my exponential trend line, and we'll keep that blue. There we go. Okay, what I'm trying to point out is, and I know this can be difficult to see, but the idea here is that that exponential trend line actually does a better job of explaining the trend than that linear trend line. Now, this does get a little bit more complicated, and the idea that the author is trying to bring up is this. Be careful. Not all trends are linear, right? A lot of our data trends could be nonlinear, and that's what the author is trying to get at, and I hope that you can see that in this graph, is that this cholesterol data has a nonlinear trend in it. Well, the point is, if your data has a nonlinear trend, that gives us an indication of other forecasting tools that we would want to use. Now, I'll be honest with you, for this class, the nonlinear forecasting methods are beyond this class. So you're not going to have to worry about that. We're just going to stick with stationary time series data and trend data. But in the real world, when you guys are working, let it be in the back of your mind that you'd better check, if your data has kind of this nonlinear look to it, you had better check for the, in Excel at least, check for the exponential trend line, all right, to see if that actually fits your data better. Okay, so enough with that. The next one that I do want to talk about is seasonality. So this is the umbrella example, so I'll get that out. Okay, so what does this look like? Now this is something that we can deal with in this class. So first, as always, graph your data. So I'll get that. Okay, perfecto. I'm going to move my chart. Okay, so let's insert our trend line. Okay, well again, this looks pretty stationary, all right? So we've got this constant mean, each period has the same mean, and we just have these random fluctuations around that mean. But here, and I admit, it's hard to see this in its current format. But here we have some seasonality in our data. So, if you read the book, obviously umbrella cells, they're going to peak, say, in the spring months when you get all the rain, and then peter out, right? Well, it's hard to see that when you just put in, time period 1, 2, 3 down here in the bottom. So what I want to do is show you a way to include both the year and the quarter, right? Because our data was given this way. So we had year 1, quarter 1 sales, year 1, quarter 2 sales, so on and so forth, up to 5 years. Well, when you have this data that you think might be seasonally have a seasonal component to it, right? Your data is going to come in this format. You're going to have the year, but this is also the season, right? So quarter 1 is the season, quarter 2 is a different one, so on and so forth. Your seasons could be monthly. Oddly enough, when the Labor Department, they issue labor information, right? Unemployment rates, job market participation rates, stuff like that. They release that on a monthly basis. Well, it turns out that there is seasonality even in job market data, right? You can imagine that during the summer, we actually hire more people. These are firms ramping up for the summer, restaurants hiring a few college kids to staff, right? Because during the summer, we tend to go out a lot more, right? Then during the winter, now this doesn't really happen in California, but for those of you who live in a place of the country where we actually have a real winter, i.e. snow and rain and sleet and all that stuff, right? Unemployment tends to take a dip during those months because of the poor weather, all right? So what I'm trying to point out is this second column here is actually like the season. The quarter could be the season, month could be a season, semi-annually. It just depends on the data. Okay, well, enough said with that. So what I wanted to do here is in this chart, in its current format, it's hard to see the seasonality. The way to do this is to redo your horizontal axis. And it turns out that Excel is actually smart enough to include both the year and the quarter in the horizontal axis. So I want to show you how to do that. So again, go to your plot area, right click, select data, edit the horizontal axes, and here all you have to do is highlight both the year and the quarter, and Excel, come on, there we go. Excel will actually put both of them in your chart. So you can see here the bottom number is the year, right? Here's year 1, quarter 1. Year 1, quarter 2, year 1, quarter 3, so on and so forth up until we get to the 5th year. Well, now that I have my seasons, if you will, in my chart, you can clearly see that quarter 2 for umbrella cells peak. So in year 1, quarter 2, umbrella cells hit a peak. Here, year 2, quarter 2, umbrella cells hit a peak. Here, year 3, quarter 2, year 4, quarter 2, year 5, quarter 2. And then conversely, year 1, period 4, they were at a low. Year 2, period 4, low for that year, right? Year 3, quarter 4, they were at a low, so on and so forth. So when I put in my quarters or my seasons on the bottom of my graph, I can really get clearly, quickly, and easily see that yes, this data is stationary, but it also has some seasonality to it, right? I hit a peak in Q2 of every year and a trough in Q4 of every year, all right? And I kind of misspoke. I wouldn't. This data is somewhat stationary, right? I certainly going to have a constant mean, but the deviations from that mean aren't quite as random as in the gasoline cells, because I know that in quarter 2 I'm always going to be well above the mean, and I also know that in quarter 4 I'm going to be well below the mean, right? So I've lost that randomness to this data, right? Why? Because this data has this seasonal component to it. And again, my data has this seasonal component. I can use that information to help improve my forecast, say for period 6, year 6, quarter 1 forecast, all right? And that, we'll get into that in the second week. All right, so the last one that I wanted to show you, there's one more that complicates things, and that is seasonal data with a trend in it. So this is the TV sales, and I'm going to graph this for you. Okay, move my chart. Okay, so first let me get my seasons in there. So I'm going to edit the horizontal axes, highlight both my year and quarter. Okay, so what am I seeing here? Quarter 2 bottoms out, quarter 2, year 2, quarter 2, year 3, quarter 2, year 4, blah, blah, blah. And then you can see the same thing here. Let's see, year 3, 4, year 2, Q4, year 1, Q4. I'm hitting the peaks in the first quarter, right? Yeah, the peaks. So I definitely have some seasonality going on. But what's interesting here is now when I add the trend line, voila, I have an upward sloping trend line, suggesting that in addition to the seasonality that's present in the data, I also have, my average is constantly on the rise, right? So yes, I do peak, the sales for TVs peak in Q4 of every year, but see that peak is getting higher and higher and higher every year. And then by the same token, the troughs in quarter 2, they keep getting higher, higher, and higher every year, right? So in this data, I have two things going on, an increasing trend and some seasonality. And again, I want to know that because that will help inform me of the forecasting method that I want to forecast Q1 of year 5. All right? Okay, so I went on a little bit long. It looks like I'm at about 26 minutes, so I apologize for that. But I wanted to go through all of these charts and you know, how do we look at this data in one video rather than breaking it apart into a couple. So, real quick, let me just summarize the following. Whenever you get your time series data, the first thing you want to do is graph it. Pardon me, and you just want a line graph, all right? The time series variable always goes on the vertical axis. The time, you know, itself goes on the horizontal. And then I strongly recommend that you always include your linear trend line, right? Unless it's rather obvious that you've got a non-linear trend going on. All right? And there you go. So again, why? Because this informs us of the type of forecasting method we want to use. All right? So there is the first, that's section, 15.1. You know, make sure you guys feel comfortable doing this. These files are posted on the website. So I would strongly encourage you to go through and get some practice graphing all these, inserting the trend lines, and doing stuff like that. All right? Okay, so enough for today.